In section 37, we're exploring the relationship between tables of values for equations and their solutions. So we're asked to graph or enter in two equations, y1 equals 3x plus 1 and y sub 2 equals 3 to the x, into our calculator, and then use a table to start to analyze some different values. So the first thing we're going to do is we're going to take those equations and we're going to plug them in. So we're going to go to y1 and go to y equals. And for y1, we're going to type in 3x plus 1. Oops, and I entered that in wrong. Sorry about that. 3x plus 1. And in y2, we're going to type 3 to the x. All right. Now, the question also says you want to set up our table in an appropriate way, so you want to make sure that we go to our table set. And good thing I did, because my table set is strange. I'm going to change it to a 0. And my delta table is 1. Now once I have that, I'm going to go ahead and pull up the table by pressing second graph. Now you see we got our table of values listed out. This is y1, and this equation again was y equals 3x plus 1. And this is y2 values, and that equation was y equals 3 to the x. What we're trying to do is figure out, first of all, what's the pattern in y1? So what are we doing every single time to get the next value? It appears that we're just adding 3. And that would be consistent with a linear equation that we're going to add or subtract the same number every time. And in y2, our pattern is to multiply by 3. Now this equation is exponential, and that would fit that pattern of an exponential relationship that we're multiplying by the same number every single time to get subsequent values. The third question says, for what value of x will y1 and y2 have the same value? Well, that happens here when the y values are both equal to 1. And that happens when x is equal to 0. Question 4 asks us, when will y2 have a greater value than y1? So that looks like it's going to happen right here when we have a 9 as opposed to a 7. That's the first time that y2 is bigger than y1. So that'll happen when x is equal to 2. And the fifth question, predict which equation will have a larger value at x equals 50. Again, predict, not actually find out, but predict and explain their reasoning. y2 is going to have that greater value because multiplying a number by 3 is way more powerful than adding 3. All right? And at some point, we already figured out that x equals 2, y2 is a bigger value, or has a bigger value. So at x equals 50, we're going to expect that pattern to continue. In activity 1, we're asked to identify the table as being linear or exponential, and then we'll take those tables and actually match them with two equations. So what I'm really looking for is what's the pattern with my numbers. And for 5 of these, it's fairly easy to find out what that pattern is. So on part A, looks like we're adding 1 every single time. That would be a linear relationship. We're adding 1 to the output, adding the same number. In B, we are doubling our output, so we're multiplying by 2 every time. That's an exponential relationship. That's what we would expect. In C, I'm going to be subtracting 2. That's linear. And D is a challenging one because of the fact that we have those fractions. So what ends up happening here is we're going to be adding 1/2 every single time. Again, adding the same number every time gives you a linear equation. And then E, we have 4 times 2 times 1, or 4, 2, 1. We're multiplying by 1/2, or dividing by 2 is another way to think of it. But that's going to be an exponential relationship. F is the tough one because we're not really adding anything, and we're not really multiplying by anything, because something's happening with this equation. But let's take a look at it. If we were to add here, we'd be adding 1/2, then 1, then 2, and then 4. Multiplying gets way trickier than that. We have 3/2, we're trying to turn that into a 2. That's a multiply by 4/3. Then we'd have to multiply by 3/2, then 5/3, then 9/5. There's really no pattern going on with that. However, going back to the linear relationship, if we're going to explore that, we would add 1/2, then 1, then 2, and then 4. That number that I'm adding every single time is doubling. And that leads me to believe that I've got an exponential relationship. So in the next part of the activity, we're taking those equations down here at the bottom, and we're trying to match them up with the tables up at the top. Now again, to do this, we're just going to pull up a table. We're going to go to y1, and we're going to type this equation in, and we're going to look for the table that matches up best. And F is the one that matches up best. And same thing with D. We're going to type, number 2, we're going to type this equation in. We're going to look for the table that matches up best with this. Something to keep in mind, though, when you get to these numbers here, they're not going to be written as fractions in the table on the calculator. They'll be written as decimals. So we have to know that negative 5/2 is negative 2.5. In activity 2, we're given 3 equations. y1 equals 2 to the x, y2 equals 2 to the x minus 1, and y3 is 2 to the x minus 2 to the quantity x minus 1. Again, very similar equations, but a slight difference in where that negative 1 is located, and that's what we have to be very careful of. Look, so first let's enter those into the calculator. So I'm going to clear all this old stuff out. I'm going to go to y equals, and I'm going to clear out these old equations. And into y1, I'm going to type 2 to the x. Oops, there we go. Into y2, I'm going to type 2 to the x plus 1. Nope, sorry, it's minus 1. I knew that was wrong. Alright, so 2 to the x minus 1. And then, there we go. X, and then we're going to get out of that exponent, minus 1. I almost made the cardinal sin there, not moving out of your exponent. Then we're going to move 2 to the x minus 1, all of it in the exponent. So we have our 3 equations entered in. Now we can go ahead and take a look at our table. We should have it already set up from before, but I'm just going to double check, and it is good. So I'm going to go to second table and take a look at my equations. So again, y1 is 2 to the x, y2 is 2 to the x minus 1, and y3 is 2 to the x minus 1. Okay, notice how the difference in how they're written. All right, we're going to go ahead and take a look at the questions then. We're asked to find where 2 to the x minus 1 equals 7. So I'm going to look for where that equation is, 2 to the x minus 1 without the 1 in the exponent. I want to know where that's equal to 7. So all I'm going to do is go to y2 where it equals 7. And that happens when x is 3. So that's my answer. If x is 3, the output would be 7. Now do the same thing for number 2. 2 to the x minus 1. So I'm looking at y3. And I want to know where that's equal to 8. And that happens here at x equals 4. And the rest of the questions are the same thing. It's just a matter of which equation are you going to use, and then find the x value that makes it happen. And then number 7 says, explain how you would do that. Well, you're going to enter in the equation. We've already done that. We're going to go to the table for y3, because that's the equation that matches up with 2 to the x minus 1. And we're going to look for the x input that gives us an output of 64. And that would happen when y is equal to 7, or x equals 7, I believe. And then the table represents a linear relationship. What's the value of y when x equals 2? Our pattern for linear then is adding 4, so we just continue that pattern to get 9. And then the other question asks us if it represents an exponential relationship. What's the value of y when x is 2? So our pattern here is multiplying by 5. If we continue that, we'll get 25. And those are the values that we're